The world's climate is changing, and the UK is committed to an 80% reduction in greenhouse gas emissions by 2050. Because about half of our emissions come from buildings, about half of the cuts will have to come from the built environment. Some of the reduction will come about through more efficient buildings and improved technology, such as lighting and computers. But emissions targets will only be met if people start using energy in different ways. Most people understand that the fuel efficiency of a car at 30 miles per gallon is reasonable, at 50 it's very good, and at 7 miles per gallon it's poor. But not many people understand what a fuel-efficient home would be in terms of kilowatt hours per meter squared of the house. There is a great need to improve people's understanding of what makes an energy-efficient home.
ENLITEN is a project financed by the Engineering and Physical Sciences Research Council. ENLITEN is designed to monitor the energy use in the home and turn that into a series of charts or sentences in English that are expressed to the homeowner, where they are using energy and how much energy they can save. The first thing we plan to do is instrument about 300 homes with sensors that are capable of detecting humidity, temperature, whether the radiators are turned on, whether the television is switched on, to get a good idea of how people use energy in their home and then how much money they might save by suppressing their energy consumption.
A central part of the ENLITEN project concerns energy literacy, and it's right there in the name. People's understanding of the energy that they use. And in the Department of Psychology, we're involved in trying to get more information about that. How do people understand the energy that's consumed in their home? One of the problems is that people don't really understand energy use at the moment, and it's not their fault, it's because energy use in the home is pretty much invisible. You do something like turn on a switch or turn off an appliance like your washing machine, and you don't get any feedback on this. You don't see what difference that has made until perhaps 3 months later when you get an estimated bill. So there's no information to guide your behaviour or help you understand the consequences of your energy use. We've had, for example, home energy smart meters for quite a long time, but they don't make a great deal of difference. And so the question is why? And it looks as though the information that they provide to people is in the wrong form. It's in the forms that engineers tend to understand, but not the forms that householders understand. So we're looking to better understand people's knowledge about energy so that the information we give them can be tailored to the terms that make sense to them. And that's really why we have psychologists involved in what is, after all, an engineering project.
So in the computer science part of this project, we're going to be developing a tool to help people as they make decisions about their energy usage. And we're going to have to gather data, and some of that data will come from sensors that we're putting around people's homes. Some of that data people will input explicitly themselves, and some of it will draw from other data sources that we have anyway. And then we're going to have to represent the results to people. So we're going to have, we want to work out what it is to show people information in a way that's useful to them in the right form at the right time.
One of the interesting things that the Department of Electronic and Electrical Engineering will be doing within the project is thinking about changes to tariffs. Maybe if we had very advanced tariffs, such that an Android tablet told people that if they turned off their washing machine now, it would save them a certain amount of money compared with if they ran it overnight, people would willingly press a button, change tariff and save money. If you look at identical households, as far as income is concerned, and number of people in identical houses, there's a fourfold difference in energy use between the worst and the best of those houses. So, we know that if we can change user behaviour, we can save an awful lot of energy from buildings.